Welcome back to Step Electrical. Friends, we are going to learn about star and delta connection of the circuits. So let's begin. In this figure, we see that these resistors are arranged in star. Here, there are three resistors R1, R2 and R3. And each of these resistors are arranged in such a way that one end of each of these resistors are connected at different terminals, but other end is connected at common point. So for R1, its one end is connected at terminal 1, but another end is connected with terminal N. One end of R2 is connected at terminal 2, but another end at common point N or common terminal N. Similarly, R3, one end is connected with 3, but another end with common point N. So on collectively we can say that star arrangement of the resistors are in such a way that one ends are connected with different terminals with 3 different terminals, but another end are connected to a common point. Some other examples of star fashion are, again here this is in star. Why? Because one ends are connected at common point and all other ends are connected with separate terminals. Again here, one ends are connected at common point, that is N, but all other ends are connected at different separate terminals. So these all figure represents the star arrangement of the resistors. So don't be confused, it is just introduction about the star configuration, star arrangement of circuits. Now these resistors are connected in delta, but how? Here there are three resistors R12, R23 and R31. R12 lies between terminals 1 and 2, R23 lies between terminals 2 and 3, and R31 lies between the terminals 3 and 1. In this way, if resistors are arranged, and we can say they are arranged in delta fashion. So some other examples of delta are, here R12 is connected between terminals 1 and 2, R23 is connected between terminals 2 and 3, and R31 is connected between terminals 3 and 1. So again this one is in delta fashion. And the last one, here R12 is connected between this terminal 1 and 2, R23 connected between terminal 2 and 3, and R31 is connected between terminals 3 and 1. So it is again in delta. So this is all about a delta arrangement of the resistors. And don't be confused, and by observing this all figure you can easily recognize if the given circuits are arranged in star or delta or not. Now let's talk about delta to star transformation. Here the given circuit is in delta and now we have to convert it into star. Let's find out. Okay, first of all we are given this delta circuit. Now we have to convert it into a star. So first of all let's imagine that we have a star connection of the resistors, and they are as, here R1, R2 and R3 are arranged in star, and now R1 lies between R12 and R31, R2 lies between R12 and R23, and R3 lies between R31 and R23. So first of all we will write the formula for R1 and then we will understand for the R2 and R3. So let's write. For R1, first of all R1 lies between R12 and R31. So find the product of R12 and R31 and then divide by the sum of resistance of all these resistors, that is R12 plus R23 plus R31, and we will get the value of R1. And from this we get the idea how to find for R2 and R3. So we can write for R2 as R2 lies between R12 and R23. So R2 equals R12 into R23 divided by R12 plus R23 plus R31. And for R3 we can write R23 into R31 divided by R12 plus R23 plus R31. In this way we can write for R2 and R3. So let's write the formula. This is all about delta to star transformation. Here in star to delta transformation, the given circuit is in star. Now we have to convert it into delta. So here how to convert a given circuit, or how to find the delta equivalent of a star. So let's find. Since the given circuit is in star, now let's imagine that we have a delta registers are arranged as R1, R23 and R31. This is our imagination that we have to find out this R12, R23 and R31 which are in this circuit. So here R12 lies between R1 and R2, R23 lies between R2 and R3, and R31 lies between R3 and R1. So first of all, how to find this all unknown resistance of these resistors? So first of all, we will write the formula for R12. So let's write. Here R12 equals R1 plus R2 plus R1 into R2 divided by R3. R12 lies between R1 and R2. We can write R12 equals R1 plus R2 plus R1 into R2 divided by R3, and it is R12. We get R12, we get the value of R12. Okay, from this formula we get idea how to write for R23 and R31. So for R23 we can write R23 lies between this R2 and R3. So we can write for R23 R2 plus R3 plus R2 into R3 divided by R1. And for R31 we can write R3 lies between R3 and R1. So for R3 we can write R3 plus R1 or R1 plus R3 plus R1 into R3 divided by R. So the formula for R23 and R31 is so this is all about a star to delta transformation, and you have to recall this formula time and again so that you will never forget. This is all about a star to delta transformation. Thanks for watching this video. If you find this video interesting, please like this video, share this video and subscribe this channel. Okay, hope to see you next video.